Hello everyone, welcome to the special session on CSAT PYQs. So in this particular series, we are solving the old question papers of CSAT. So in that aspect, I will be going from 2024 and backwards. So 2024, 23, 22, 21 until the start of the CSAT papers. So let me start with this 2024 preliminary examinations paper 2. I have directly gone to the paper which is put up by UPSC in their website. So this is Civil Services Preliminary Examination 2024 and Paper 2. In this, I'll be solving only the quantitative aptitude and the logical reasoning questions. RC we are not dealing in this particular session. So let me go to the questions straight away. In these questions, I'll be taking up the quantitative aptitude and the logical reasoning questions as and when they come. So here we have at fifth position. Here this is asking about a particular thing in cubes. So this question is related to cube. So here they are asking cubes. What is the least possible number of cuts required to cut a cube into 64 identical pieces? See, you take any solid cube and try to give a cut. You will not get the shape of the cubes unless you cut at equal intervals on each edge and the same number of cuts on each edge. This is what is the application of learning cubes. So when you want to make a cube into different smaller cubes or n number of smaller cubes, what you have to think is you have to look at like how many cubes, smaller cubes you need. 64. This is nothing but 4 cube. That means on each edge of a cube, if you take this cube, on each edge of a cube, you have to get 4 pieces. To get these 4 pieces, you need to give 3 cuts. These are 4 pieces. Again, here I am giving 3 cuts. Similarly, it will go like this. We need to connect these things. So totally we have 64 here. But to get 4 cubes on each edge, this is one edge, this is length, this is breadth, and this is height. Length, breadth, and height. On each of the edge, I need to get 4 cubes. So for that, I need to give 3 cuts. 3 cuts on the length, 3 cuts on the breadth, and 3 cuts on the height. I am talking about the cuts. not the number of pieces. To get these number of pieces, I need to get 3 cuts on each dimension. So 3 plus 3 plus 3, totally 9. This is a straight question, but UPSC is going to a different dimension in all the chapters now. Earlier, they used to ask about how many cubes exist in the corner on each edge, how many of them are painted in 2 faces, 3 faces, 1 face, no paint, like that they used to ask. But they are going to a different level because they know that we read these chapters, we study these chapters, and whether we have understood the concept in totality or not, they are checking those things. That is where the UPSC is reaching now. So concept remains the same, but to what depth UPSC is going, that we need to check. Next one. So I'll be going question by question. So 6th. So now the question number 6. So in this, we need to look at what they are asking. So in this question, they are asking 5 star, 4 star, 3 star, 2 star, 1. This is an expression where the star gives certain symbols, that is plus, minus, and multiplication, each at most 2 times. So there are 4 symbols here, and we have been given choice among 3 different symbols. So one symbol can be used at the most 2 times. That means we can use a few, but they are asking each, chosen from each. So we have to take at least once. So plus ones, minus ones, and multiplication ones, and one more symbol later. Which symbol? We don't know. What is the smallest non-negative value? For us, the smallest non-negative value is 1. Smallest non-negative value. We cannot take 0 as either positive or negative. When they say non-negative, we have to go for the positive one. So here 1 we have to target, but we'll see. Minimum it has to be 1, or else it can be 3, 2 or 1. So 0, whether it comes into picture or not, we will see later. But let us look at this. 5, 4, 3, 2, 1. And here our aim is to get the minimum. So we need not go for the product of bigger numbers or the sum of bigger numbers. We try to minimize. See, 5 and 4, whether you add it or multiply with each other, then it will give us bigger value. So better we need to use subtraction here. 5 minus 4, it can give me 1. But when it comes to usage of multiplication, we have to try to use this multiplication mark with the smallest numbers. Among these, the smallest numbers are 2 and 1. So here I'll put 2 into 1. So according to BODMAS, we have to do this first, because among these, multiplication has highest priority. So we have to do this. And again, to reduce the effect. What we can do? 5 minus 4 is 1. Then again, if you do minus 3, then plus this one. So 5 minus 4 minus 3 plus 2. So this will be 5 minus 4 minus 3 and plus 2. What will give? 5 plus 2 is 7. Then 7 minus 7 is equal to 0. 7 minus 7 is equal to 0. Now I need to check whether we are going right or wrong. They are asking what is the smallest non-negative value. So negative value starts from anything below 0. Let's say minus 0.0000 or whatever it is. But what about 0? 0 is neither negative nor positive. When I need positive, then I will start with some value like 0.000001 maybe, or beyond that. So here starts the positive, here starts the negative. They are asking non-negative value. Non-negative value can be 0. Non-negative value. So I told you 0 is neither positive nor negative. So we can consider 0 as the non-negative value and we can put this as the answer. So doing many operations here, I can get 1 or 2 or 3 as the answer. But our aim is what? Go for the smallest value, that too the non-negative. Then we have to 0 upon 0 here. So this is how we have to solve. Minus is used twice, plus is used once, and multiplication is used once. So let us go to the next question. Yeah, 7th question. It is talking about a certain number of men can complete a piece of work in 6K days. A group of men, a certain number of men require 6K days. I don't know. 6K means it can be 6, it can be 12, it can be 8, because K is a natural number they have given. So multiples of 6, 12, 18, it can be the multiple of 6. By what percent should the number of men be increased so that the work can be completed in 5K days? So here we need to do a shortcut. So usually these type of questions are related to a fixed budget. Whenever we have a fixed budget, so here fixed budget in the sense, here it is the fixed work. Work is not going to change. Only the number of men who are doing the work will change, and only the number of days those men are taking will change. But the entire work remains the same, because the number of men into the number of days what we are employing, whether it is different number of men, different number of days. So always these will remain constant. So even with respect to price rise and the consumption, when the price rise happens, we tend to consume less with the same budget. So these are called as same budget problems. So in such problems, we need to employ one shortcut. That is, earlier they used to take 6K days. Now they are tending to take only 5K days. So earlier it was 6K day. Now they are taking 5K days. So the reduction in number of days is K. But on the basis of what? Earlier 6K days were taken. Now K days are less. So this is 1 by 6. That means the number of days reduced by 1 by 6. So whenever we reduce the number of days, we have to increase the number of men. So when we have reduced the number of days by 1 by 6, I'll give a straight calculation. When we have reduced the number of days by 1 by 6, we have to increase the number of men by 1 by 5. When we have reduced it by 1 by 6, it has to be, the number of men who are working at this should be increased by 1 by 5. So for this, we have one particular shortcut. Whenever you reduce the other part by 1 by x, the complementary part has to be increased by 1 by x minus 1. Or whenever you increase something by 1 by x, the complementary part you have to decrease by x plus 1. This is the shortcut. This is very much applicable in many of the aspects. Here, complementary things are what? Men and number of days. Number of men and number of days are inversely proportional. Whenever you multiply number of men and number of days, it has to give you a constant value, that is one fixed work. So when we increase the number of days, we have to reduce the number of men. When you decrease the number of days, you have to increase the number of men. So in such cases, if you adopt this shortcut, it will definitely help. The number of men decreased, number of days decreased by 1 by 6. So number of men will be increased by 1 by 5. So this is the answer. So 1 by 5 is straight away 20%. So 20% is the answer. We'll go to the next question. Now 7th one is done. 8th one. This is again associated with the time and work. Time and work, it is associated with XYZ can complete a piece of work in 6 hours, 8 hours and 8 hours respectively. So X, Y, Z have different capacities, but here X has 6 hours as capacity. That means he can finish one work in 6 hours and Y and Z will take 8 hours. In this, we have to understand that X is more efficient worker because he can finish in less time compared to Y and Z. That is what is the crux of the question. However, only one person at a time can work in each hour. Each hour we are allocating the work. So in each hour, one person has to work. Nobody can work for 2 consecutive hours. That means if X works on the first hour, second hour he cannot work. All are engaged to finish the work. That means we have to employ everyone, X, Y and Z. We should not give leave to one person. So all 3 have to be used. What is the minimum amount of time that they will take to finish the work? Here the demand is minimum time. So when 3 workers are there, one is more efficient, 2 are relatively less efficient. In that case, what do? You will try to employ that person more. Here X is most efficient person. I am going to employ that person more. That means the first hour I'll give it to X. So how much of the work is finished in first hour? That is 1 by 6. When he can finish the entire work in 6 hours, he can finish 1/6 of the work in 1 hour. Next, second hour. He is not supposed to work because after 1 hour, we have to give the break. You can employ him for the third hour. Definitely I will employ because I need more work to be done. Compared to Y and Z, X is more efficient. I am going to employ him more. But what is the condition? He should not work for 2 consecutive hours. But if I am using him for the first hour, I will be using him in the third hour also. Here, I'll take either Y or Z. Let me take Y here. So how much of the work will be finished? 1 by 8. Next hour, that is third hour. Again, I am going to employ X because I want to finish the work as early as possible. So again here, 1 by 6. Now I will employ Z in the 4th hour. So it is 1 by 8. Like this, I am going to assign the work to X in alternative hours. But what is the cycle here? First hour is done by X, second hour is done by Y or Z. So see how much is the work done here. 1 by 6 plus 1 by 8 will give me 14 by 48, or it is equal to 7 by 24. So in 2 hours, 7 by 24 of the work is done. So in 4 hours, 14 by 24 is done. In 6 hours, that is in 5th hour and 6th hour totally, my work will be again 1 by 6 and 1 by 8. So 7, 14, 21. So 21 by 24 of the work will be done in 6 hours. So 6 hours, I have done 21 by 24 work. So how much of the work is done if 21 by 24 work is done? So now is remaining only 3 by 24 of the work. So 3 by 24 is nothing but 1 by 8. So 1 by 8 of the work is remaining. But whom I will employ again? 6 hours work is done. And 6th hour is done by either Y or Z. I will employ X again because I want to finish the work early. So how much of the work is remaining? The work remaining is 1 by 8. And whom I am employing? I am employing X again. So what is the capacity of X? 1 by 6. So this is the work remaining, and capacity of X is this 1 by 6. So if you solve this, 6 will go up, 8 will come down, it is 6 by 8, so 3 by 4. So in the 7th hour, A will work for 3 by 4 hours. 3 by 4 hours is nothing by 45 minutes. 3 by 4 hours is nothing but 45 minutes. So 6 hours, they have finished this much work. To finish 1 by 8 of the work, I am employing X again. So I will take another 45 minutes to finish the work. So it is totally 6 hours and 45 minutes. 6 hours and 45 minutes. This is the answer. If you employ Y or Z in the 7th hour, they will take 1 hour to finish the work. In that case, will take 7 hours. But I want to finish it as early as possible. That is why I am employing my best worker, that is X. So this is about this problem. So this is a classical problem. Here we need to understand few things, that whenever we want 0 in our product, we should search for 2 and 5. So how many consecutive zeros are there at the end of the integer obtained in the product of this one? So they are asking how many zeros. This is related to number of zeros. So how many zeros you will get? For any 0, you need to have 10 as a factor. So if you want 0 as the last digit in any number, inherently 10 is the factor of that number. But to get 110, what all you need? 1, 2 and 1, 5. So in this expression, you have to look for the number of pairs of 2 and 5. So here 1, 2 and 1, 5, when multiplied together, we get 10. That means 1, 0. So to get the number of zeros, we have to get to the number of pairs of 2 and 5. So let me check here. Whenever you go for an expression starting with 1 and ending with some n, you don't have to worry about the number of 2's, because you will get plenty of number of 2's. But when it comes to 5's, there are limited 5's. So number of 5's are limited. So if you focus on only the number of 5's, because you know that the number of 2's that you get is huge. So you don't have to worry about in such an expression where the continuous, that is the consecutive numbers are given with some variation. That's fine. So here I will try to go for the terms which will give me 5 as a factor. So if I go like this, I will be looking for 5 to the power of 10. Then 10 to the power of 20, then 15 to the power of 30, then 20 to the power of 40, and 25 to the power of 50. So here, this is nothing but 5 into 5 into 5, 10 times I am multiplying 5. So number of 5's I get is 10. Here, number of 5's I get, this is 2 into 5. This is 2 to the power of 20 into 5 to the power of 20. The number of 5's I get is 20. So similarly here, I'll get 35's and here I'll get 45s. But in this case, this is nothing but 5 into 5 whole to the power of 50. This is nothing but 5 square whole to the power of 50. This is nothing but 5 to the power of 100. So in this expression, the number of 5s I get is 100. So these are the number of 5s that we are getting in this expression. I am not worried about the number of 2s here because we get plenty of number of 2s. For example, here 24 to the power of 48. In this 24 only, I get 2 into 2 into 2 thrice. So that is 2 to the power of 3 to the power of 48. That is 2 to the power of 144. I get n number of 2s here. Don't worry about that. Look for only 5s. So 10 plus 20 plus 30 plus 40 is 100 plus 100. So the number of 5s that I get is 200. So I'll get those many numbers of zeros. So 200 zeros I will get. So 200 5s I am getting. So this is the answer. Okay, 9th is done. This is related to calendar. On January 1st, 2023, one person saved rupees 1. So on January 1st, 1 rupee is saved. On January 2nd, he saved 2 more than that of the previous. So 1 he had saved on 1st January. On 2nd January, he will save 2 more. That means he is saving 3. On 3rd January, he saved 2 more than that of the previous day. So it will just go on like that. So his savings are 1, 3, 5, then 7, then 9, 11. So where we are going? Actually, we are going with the consecutive odd numbers. So first day saving is 1, second day saving is 3, third day saving is 5. This is individual savings on those days, not the total. If you want the total of these savings, we have to do the sum. We have to do the sum. So first day he has 1 rupee as a saving. Second day he had 4. Third day 1 plus 3 plus 5. That is 4 plus 5, 9. Then on 4th day 9 plus 7, 16. On 5th day he had 25. On 6th day he had 36. What we are hitting actually? So at the end of which date his total savings a perfect square as well as a perfect cube. So we have to look for that number which is both a square and a cube. And what is that smallest number? See, 1 is the smallest cube and smallest square. That is 1 square and 1 cube. So when you go like this, for example, 2 cube is 8. 2 square is 4. So you have to look for a number, the smallest number, which is both a square and a cube. So if you go like this, that is 1, 4, 9, 16, 25, 36, then 49, then 64. 64 is that number which is both a square and a cube. And it is nothing but 8 square and also it is 4 cube. 8 square and 4 cube. So what we are seeing here, on first day the saving is 1. On the second day 2 square. On third day 3 square. On fourth day 4 square. On fifth day 5 square. And sixth day 6 square. I need 8 square. So 8 square is nothing but 64. So on 8th day, he'll be having the savings as 64. That is the answer. So what is the application? Like why they are asking this question and where we have to hit this one? So this is nothing but the sum of the consecutive odd numbers. So the sum of first n odd numbers is nothing but n square. So if you want to write it somewhere, you can write it. The sum of first n odd numbers. The sum of first n odd numbers is equal to n square. Okay, keep this thing in mind. It might help you somewhere else also. But they have clubbed it with calendar. It is not purely calendar problem. This is number system problem where we have to know the number of squares and number of cubes and which all are those numbers which gives us both square and cube. And one more thing, like the sum of the consecutive odd numbers, sum of first n odd numbers is nothing but n square. This is the application of it. So we'll go to the next question. 222 to the power of 333, 333 to the power of 222 is divisible by which of the following numbers? Okay, for this You have to understand these 222 and 333, which are bases. Don't worry about the powers right now. Most of the things are decided on the bases. So here, bases are 222 and 333. These are the multiples of 111. And by now, the aspirants of civil service should be knowing the importance of 111, because every year we get one or the other question on 111. 111 is nothing but 3 into 37. It is a multiple of 3. It is a multiple of 37. So 111 is 3 into 37. So we have to understand that the factors of these are 37 for sure. 37 for sure. So if I write 222, 222 is nothing but 37 into 6. So whole to the power of 333. And next, 333 is nothing but 37 into 9 to the power of 222. Yeah. What they are asking? These are divisible by what? Definitely these numbers are divisible by 37. And these numbers are divisible by 3 for sure. But what we have to decide? See, 3 and 37, yeah, yes. 2 and 37, I am not sure. 2, 3 and 37, I know only about 3 and 37. But whether 2 or not, that I have to check now. Whether 2 or not. See, if you look at this number, the base is even number and power can be anything. So on the base of an even number, if you put any power, the answer is going to be even. Even to the power of anything is an even number. Then similarly here, base is odd. Anything to the power odd, and upon that any power. Any power of odd will give me the result of odd. So even plus odd is always odd. Even plus odd is always odd. So what I mean to say here is, if you have the sum of this, I'll get odd number. And any odd number is not divisible by 2. Any odd number is not divisible by 2. So definitely this is not divisible by 2. So the answer is, this expression is divisible by 3 for sure, 37 for sure, because 111 is that number that we have to be carefully watching. So 111. So 222 is a multiple of 111. So definitely 3 and 37 are the factors. For 333, 3 and 37 are the factors. But when we make the sum of these two numbers, we'll get an odd number, and any odd number on the earth is not divisible by 2. That is why this expression is not divisible by 2. Answer is B. So looking at the question, many people get a fear. What exactly is this? But don't get feared. Apply your basic knowledge. Basic knowledge is what? 111 is a multiple of 3 and a multiple of 37. That's it. Next 15 problem is done. What percent of water must be mixed with honey so as to gain 20% by selling the mixture at the cost price of honey? See, this is a classical problem of mixtures or adulteration. So whenever you need a profit of certain percentage, try to convert it into a fraction. So 20% is nothing but 1 by 5. 20% is nothing but 1 by 5. And this is the fraction. This is the fraction in which you are trying to add some adulterant. So here adulterant is water. You are trying to mix it with honey. So what is the ratio of this adulterant? This is nothing but this ratio 1 by 5. So water to the honey. Water to the honey should be in the ratio 1:5. So they are asking what percent of water must be mixed with honey so as to gain 20%. So if honey is 5 liter, I need to add 1 liter of water. So they are asking what percent of water. If 5 liter water is there, I have to add 1 liter of honey. Sorry, if 5 liter of honey is there, I have to add 1 liter of water. That is straight away 20%. So the answer is 20% itself. Answer is 20% itself. Okay. If they ask what part of the mixture is water. So here 5 liter water and 1 liter honey is there. So total mixture is 6 liters. In that, how much is water? 1. This is the part of water in the entire mixture. But they are asking what part of the honey must be added as water. So in that case, water to honey ratio is 1:5. But here, water to the entire mixture is 1/6. Don't get confused. Here, simple. They have asked the simplest thing, that is like how much of the water should be added with respect to the volume of honey. That is 1/5 or 20%. What is the rightmost digit preceding the zeros in the value of 30 to the power of 30? So this is again the last digit problem. This is what is the rightmost digit preceding the number of zeros. So how many zeros will get? See, in the base we have 30. So it has 1 0 and we are multiplying this 30 times. So indirectly we are multiplying this 10 30 times. So we'll get 30 zeros. But before that 30, before those 30 zeros, what is that number? A non-zero number, what is that? We have to find out. So let me check. What is the rightmost digit they are asking? So this expression is nothing but 3 into 10 to the power of 30. So if I express this, this is 3 to the power of 30 into 10 to the power of 30. I am going to discard this one because I don't want number of zeros. Anyways, we know that 30 zeros will come. But now focus on only this one, 3 to the power of 30. The shortcut is what? Keep the base as it is, that is 3. But when it comes to the power, divide power by 4. Divide power by 4. So 30 by 4. What is the remainder? 4 7s are 28. 7 is the quotient, but remainder is 2. Remainder is 2. So the ending digit of this expression will be 9 because 3 to the power of 2 is 9. So hence the non-zero digit what we have preceding those 30 zeros is nothing but 9. So this is the first non-zero digit that we get when we are starting to count from the right. After 30 zeros, we'll get this number, that is 9. Next question. 421 and 427, when divided by the same number, leave the remainder of 1. So whenever we divide these 421 and 427, we get the remainder as 1. So take out that one remainder first. So we'll be left with the numbers 420 and 426. These are two numbers, 420 and 426. We want to divide a number, divide these numbers by a number. That means straight away we are going for the factors of this 420 and 426. Let me read the question. How many numbers can be used as the divisor in order to get the same remainder? So in such case, you have to go for the HCF first. First find the highest common factor. So of 420 and 426, get the highest common factor. So you will divide by 2. This will be 210 and 213. Now I cannot divide by any even number because one is even, one is odd. But I can divide by 3. 370s are and 371s are. So 71 is a prime number. We cannot divide further. So the HCF is 6. HCF is 6. So 6 can divide both the numbers, and also the factors of 6 can also divide the number. So now the factors of 6 are nothing but 1, 2, 3, 6. So we can divide this 420 and 426 by all these numbers 1, 2, 3, 6. But we want the remainder as 1. If you divide any number by 1, definitely the remainder is going to be 0. So that is why I am not considering this one. But this 2, 3 and 6 can divide a number, that is 420 and 426 can be completely divisible by 2, 3 and 6. So we have three such numbers. When we divide 421 and 427 by these numbers, that is 2, 3 and 6, we will be remaining with the remainder as 1. So 3 such numbers, they are 2, 3 and 6, but not 1. If you divide any number by 1, the remainder is going to be 0. That is why we take 1 as a common factor for all the numbers. So sometimes that 1 becomes highest common factor when we don't get the common factors for given two numbers. Default HCF is 1 when you don't find any other factor for those numbers, any other common factors for those numbers. Next question. A can contains 399 liters of petrol and 532 liters of diesel is there in Y. X has petrol, Y has diesel, 399 and 532 respectively. They are to be bottled in bottles of equal size. That means we are dividing this volume. Either 399 or 532, we are dividing those volumes so that whole of petrol and diesel would be separately bottled. So we are looking for that small number which can divide both these numbers. Again, we have to go for the HCF here. So to find out the HCF of 399 and 532, you have to look for common factors. So this is odd number, this is even number. Don't try it with 2. So try with 3. You will get something? No. So 3, you will not get anything. 5, you cannot try. 7, try with 7. So 7 5s are, then 7 7s are. Here 7 7s are and 7 6s are. 57 and 76. By the nature of them, you should be able to understand that they are the multiples of 19. Only when you know the multiplication table of 19, you will get to know that 57 and 76 are the multiples. So 19 3s are and 19 4s are. So 3 and 4 cannot be further divided by any common factor. So 7 and 19 we have to multiply, and our HCF here in this case, HCF is equal to 133. HCF is equal to 133. Now they are asking that these have to be bottled in equal size. They are not asking for the maximum size. If they were asking for the bottle of maximum size, the maximum size of the bottle should have been 133 liters. But we are not going for that one. We are looking for all the possible factors of this 399 and 532. In that case, what you have to do? You have to take 133 and find the factors. So factors of 133 are nothing but 1, and anyways we know 7, 19 and 133. These are the 4 factors of 133. Indirectly, these are the 4 factors of, or 4 common factors of 399 and 532. So now the bottle capacity in terms of liter is an integer. Yes, we are looking for the integers here. 1 is an integer, 7, 19, 133, all of them are integers. How many different bottle sizes are possible? I can make the bottles of 1 liter, bottles of 7 liters each, bottles of 19 liters each, and the bottles of 133 liters each. So I get 4 such options of bottle sizes. 4 such options for bottle sizes, that is 4. Okay. Next question. See, the last 2 problems what we have solved, they are the applications of HCF. They are the applications of HCF. So in one paper, they have asked 2 questions on HCF. So that is where you have to understand the importance of number system. So please give care for the number systems. Consider the following statements in respect of S is equal to X plus Y plus Z, where X, Y, Z are distinct prime numbers. They are distinct prime numbers, like they are all different prime numbers. But whenever you come across the problems on prime numbers, you have to consider one peculiar prime number, that is 2. That is the only even prime number that we have. All other prime numbers are odd prime numbers. So you have to give extra care for that too, because that will trick the entire problem. So each less than 10, all of them are less than 10. Now We have to check which of the statements are correct. The unit digit of S can be 0 unit digit. So if the sum is S, so the unit digit, this number has to be 0. So this can be anything. And we are going for 3 distinct prime numbers, 3 distinct. So if I want the sum as 10, I can take 2 plus 3 plus 5. These are all distinct prime numbers. These are all distinct prime numbers, 2, 3, 5. The unit digit of S can be 0. Definitely yes. When I take 3 prime numbers as 2, 3 and 5, my answer, the sum is x plus y plus z. So 2 plus 3 plus 5 is equal to 10. Next, the unit digit of sum, the unit digit of S can be 9. Again, we have to look for those numbers. And here, why I am trying with these numbers? Because 2 plus 3 plus 5. So these 3 prime numbers are the smallest prime numbers that we have. Better we start with those things. So now, whenever I go for the sum, that should be equal to 9. That should be equal to 9. In that case, when you add 2 odd prime numbers, the sum will be even. Whenever you add 2 odd prime numbers, the sum will be even. Okay. But whenever you add 3 odd prime numbers, the sum will be odd. So here I will be looking for 3 odd prime numbers. So try to get those things and get the sum as 9. But using anything below 2, 3, 5, you will not get result. So next, 2, 3, 5, 7, 11, 13, 17, then 19, 23, 29. These are the prime numbers that we are looking for. So first one was satisfied by 2 plus 3 plus 5. So the unit digit of S can be 0. Now look for 9. So when you add 3 numbers, the last digit should be 9. Look for such number. For example, 5 plus 11 plus 13. The sum is 29. Yes, I can make that the number ending with 9. So this is also possible. Now, unit digits of the sum can be 5. Sum has to be 5. So here only you check 3 plus 5 plus 7. This is 15. 3 plus 5 plus 7 is 15. So even the sum can end with 5. So look at the question once again. Consider the following statements in respect of S is equal to x plus y plus z, where x, y and z are distinct prime numbers, each less than 10. So we are looking for only the prime numbers which are lesser than 10. So I should not go for beyond 10. So this is the restriction. So first one was 2, 3, 5. Yes. So here when I take the prime numbers as 2, 3, 5, I'll get the sum as 10 and the ending number is 0. But for 9, use the numbers below 10. So in that case, the unit digit of S, I am using 3 numbers. To get the sum as 9. So do any combination here. You will not get the sum of 9. In my previous attempt, I had not considered this. I was going for all the prime numbers, even above 10. But I have a restriction that I should not cross 10. So make sum of any 3 numbers here. 2, 3, 5, 2, 3, 7, then 2, 5, 7, then 3, 5, 7. Make any sum, you will not get the ending digit as 9. So this is wrong. This is right. This is wrong. Coming to this, the sum has to be 15. Yeah, straight away. 3 plus 5 plus 7. 3 plus 5 plus 7 is ending with 5. 15 is ending with 5. So 1 and 3 are correct. In this case, 1 and 3 are correct. Second one we cannot prove. So this is the answer. And they are asking only for the prime numbers which are lesser than 10. In that case, we have to go with only 2, 3, 5 and 7. So now we are done with problem number 20. Let us go for 21. So 21 is a passage. Okay, 23, 24. Yeah, 24 is the next. This is related to series. This is related to series. In such cases, what you have to do is you have to trial and error. You have to trial and error, because for such a series, there can be more than one answer also. But among the given answers, which is the right one? For that, what we have to do is we have to do the trial and error method. So you have to add the options. So you have to substitute the options here and then check. So here, if I substitute this first one, B, A, D, C, try to make sense of this. A, B, B, C, D, A, B, B, C, D, fine. A, B, C, D, D, A, B, C, C, D. See here, B is twice, B is twice, understood? But here, D is twice and C is twice. So why B, B, D, C? I don't know. I don't know the logic. Let us hold this. Let us not decide anything on this. Now, put the second one. B, A, C, D. A, B, B, C, D. A, B, B, C, D. A, B, C, C, D. A, B, C, D, D. Again, the same logic. I'm not getting convinced. Now, A, C, D. So A, B, C, D, A, B, B, C, D, A, B, C, C, D, A, B, C, D, D. See, here A is twice, here B is twice, here C is twice, and here D is twice. There is an order. There is an order that in the first expression A is getting twice, B, next C, next D. So that makes sense. So even if you substitute this one, here you will get DD and here you will get CD. So here A, B, D, C is not an order. So the ultimate answer is C. So in such cases, you have to go for trial and error. You have to go for the reverse engineering. That is, apply the options, put the options and then check. That will help you, because for one question, for one pattern, there can be more than two right answers, or there can be more than one right answer. I'm sorry. So better you check from the options and decide. Yeah. For this question, two persons, P and Q, enter into a business. So this is partnership problem. In the first sentence only, we will get to know what chapter it is. So it is partnership. Two persons, P and Q, enter into a business. P puts 14,000 more than Q. P has invested for 8 months and Q has invested for 10 months. So whenever you take the investment of two persons, so always their investment matters and their time period for which they are investing. So P is investing for 8 months and Q is investing for 10 months. And here P puts 14,000 more than Q. P puts 14,000 more than Q. So if Q puts Q amount, P will put Q plus 14,000. So if Q puts the amount Q, P will put 14,000 more. Then their profit ratio will be shared in this aspect only. That is, Q plus 14,000 into 8 plus, sorry, not plus, is to Q is to 10. So this is how they share the profit. If P's share is 400 more than Q's share out of the total profit of 2,000. So out of total profit of 2,000, P's share is 400 more. So give 400 rupees to P. Then in the remaining 1,600, because total profit is 2,000, in the remaining profit of 1,600, they are dividing with each other because 400 is more. So I am taking that 400 out of the calculation. Now I am distributing this 1600. In 1600, 800 will go to P and 800 will go to Q. So if you take the ratio, this is 1200 is to 800. 1200 is to 800 is nothing but 3 is to 2. So whenever you take the ratio of this, that should be there as 3 is to 2. So how to do that? So here, if you can cancel 2 4s are and 2 5s are. So when you multiply this, 4Q plus 56,000 divided by 5Q is equal to 3 is to 2. So cross multiply, 2 4s are 8Q plus 56,000 into 2 is 1,12,000 is equal to 15Q. If you bring 8Q this side, that will become 7Q is equal to 1,12,000. So Q is equal to 1,12,000 divided by 7. So this is 16,000. Q is equal to 16,000. So 7 16s are 112. So what they are asking? What is the capital contributed by P? If Q has contributed 16,000, P has contributed 14,000 more. So contribution of P is 30,000. So this is a bit a complicated problem in partnership, but one concept will remain the same. That is, the profit they are sharing should be in the ratio of their investment and also should be in the ratio of their time period for which they have invested. So simply here P1 is to P2, profit 1 to profit 2 is I1 T1, that is investment and the time period, to I2 T2, that is investment into time period. This is how we have decided, and finally we have arrived at a solution that P's investment is 30,000 and Q's investment is 16,000. P has invested for 8 months, Q has invested for 10 months. At the end, P is getting 400 more than that of the Q, but the total profit is 2,000. So P's share will be 1,200 and Q's share will be 800. That is what is 3:2 ratio. 3:2 ratio. This ratio should be equal to 3:2. That is what I have tried to solve. Next question, 26. Yeah. P's salary is 20% lower than the Q's salary, which is lower than R salary. So if you take these persons, P, Q and R, P's salary is compared to Q's salary and Q's salary is compared to R salary. P's salary is 20% lower than Q's salary, which is 20% lower than R salary. So finally, everything is being compared to R salary. If I take R salary as 100, Q's salary is 20% lower than R salary, that is 80, and P's salary is 20% lower than 80. I cannot write 60, but it is 64 because 64 is 80% of 80. If you write 60 there, it's wrong. So 80 is 80% of 100, 64 is 80% of 80. So these are the ratios in which they are getting the salary. 64 is to 80 is to 100. By how much percent is R salary more than that of the P salary? So compared to P salary, R salary is 36 more. But if you compare, so 36 compared to 64, 36 compared to 64, it gives me the result 9 by 16. 9 by 16. 9 by 16, if you multiply by 100% to this, the answer will be 56.5. 56.25%. Answer will be 56.25%. What they are asking, this 100 is how much percentage more than 64? It is not 36% more. It is 36 more. But what we are comparing to? So that comes in the denominator. In percentage problems, denominator is the ultimate thing. If you know what is denominator, you will get the answer for sure. So here denominator was 64 because we are comparing it to piece salary. Piece salary is 64. How much more? 36. Convert it into percentage. That is 56.25%. Now, similar to the percentage problem only, a number is mistakenly divided by 4 instead of multiplying by 4. Let me take a number as, let's say, x. Actually, I had to multiply this number by 4, but mistakenly I have divided this number by 4. So actual number has to be 4x, but I am getting x by 4. So it has changed drastically. It has changed drastically. So it has to be, let's say, 4 into x, let's say 400, let's say. But now it is 100 by 4, 25. Look at the ratio. Look at the ratio. 400 to 25. It is drastically changed, significantly changed. They are asking, what is the percentage change in the result? So it had to be 4x. So we are comparing it to 4x. But how much is the change? If it has to be 4x, this is a bigger number, but it has turned down to be x minus 4, x by 4. So the change is 4x minus x by 4. So if you take this as 4x, so here 4 and here 15x, 16x minus x is 15x. So totally 15x divided by 16x. So x get cancelled. This is the change. 15 by 16 is the change. If you want to convert it into a percentage, 15 by 16 is close to 100%. So answer must be this, but let me verify. 15 by 16 into 100. 15 by 16 into 100. Here 4 4s are 425s are. 15 into 25 is 375 by 4. It is 56.25%. It is 56.25%. I'm sorry. This is 4 9s are, then 4 3s are, then 3 is left, 7 and 5. 93.75% is the answer. So you can see here 4x is being reduced to x by 4. Significant change. Significant change. Almost close to 100% change. But somewhere below 100%, even if you make a guess here, you will come close to this answer, that is 93.75%. Let us look at this question. In an examination, 80% of students passed in English, 70% of students passed in Hindi, and 15% failed in both the subjects. So this is Venn diagram problem. Here Hindi and English are two entities. As soon as you get there are two entities, you have to draw this diagram. And here let me look at the people who passed in English and people who passed in Hindi. 80% of the students passed in English. So this circle is 80%. I cannot mark here because there are two different regions in this circle. And here this is 70%. But 15% failed in both. That means I am putting them out. They have failed in both the subjects, both Hindi and English. Here are the people who have passed in both the subjects. But if you look at the total of pass, it is 150%. Because we are counting double. Many of the students have passed in two subjects. That is why it is more than 100%. But 15% people are outside. So these three sectors should give me the total of 85% because 15% are outside. So 150% minus 85% should give me 65%. That means 65% of the students have cleared both the papers. 65% of the students have cleared both the papers. And in 80% of English, 65% is failed. So another 15% have failed, have passed only in English. So similarly for Hindi, 70% minus 65%, 5% only have cleared in Hindi. That means the people who have passed only in Hindi are 5%. People who have passed only in English is 15%, and people who have passed in both is 65%, and people who have failed in both is 15%. Now what they are asking, what is the percentage of students who failed in only one subject? The people who failed in only one subject. Look at these people. These failed in both. These people failed in none because they have cleared both the papers. But these people passed in English but failed in Hindi. These people passed in Hindi but failed in English. So they are the people, this 15% and 5% are the people who have failed in one subject. So total is 20%. So this is the solution for this. Okay.